Introducing My HaasTechnology, a free feature available to anyone on HaasCNC.com. If you are a current HaasTech owner or machine operator, if you're involved in buying or maintaining HaasTech machines, and even if you are not currently a HaasTech user, but want to build and price a machine online, My HaasTechnology has something for you. Monitor machines in your shop with My Machines. Here, you can see all the machines you're responsible for and group them in whatever way you'd like. Operators and supervisors can even create their own groups in a way that makes sense to them. Click on any machine and quickly see your machine's serial number and warranty start and end dates. Scroll down for a complete list of that machine's options, including recent service updates, or with a single click, jump to the product detail page to check specs, layout drawings, even to download 3D models. In the event you need to order a part to service your machine, or if you're looking for a performance-enhancing option, HaasTech Parts is just a click away. As if that's not enough, our helpful and thorough service website is also right at your fingertips. Here, you'll find comprehensive troubleshooting guides, how-to procedures, videos, and operators manuals for just about every vintage of HaasTech machine that we've ever built. And the best part is, all of this helpful information and all of these support services are pre-filtered based on the machine you've already selected. The My HaasTech Connect tab lets you see the status of every HaasTech NGC machine in your shop at a glance. Scroll through for the current status and last recorded event for each of your machines. In My Quotes, build and price as many machines as you'd like and save them for viewing or editing later. This makes it easy to compare machines and find the one that's right for you. From there, you can send the build and price to a coworker or friend or anyone who might be involved in the buying decision. And when you're ready, send it to your local HaasTech factory outlet when it's time to move forward. My HaasTech allows you to be more efficient and manage your shop and your machines like never before. And best of all, it's completely free. Create a free My HaasTech account today.
You know, it doesn't take much effort to install the HaasTech robot package on your mill. You literally roll the robot right out of the shipping crate. All you need is a tape measure and a simple bubble level to align it. The cables that link it to your control are all clearly marked and ready to plug in. Your service tech will drill a couple of holes and move some shelving to get the enclosure ready to accommodate this huge leap forward in automation. And that's the mechanical part. But what about integration? Well, the HaasTech control is already set up for the robot, so your service tech will have the integration done in well under an hour. And that's it. It only takes about a day to get your versatile, efficient robot package installed and ready to start making you money. If you're ready to take a step into automating your production, the affordable, versatile, and easy to install HaasTech robot package could easily be what you're looking for.
Welcome to Factory Spotlight. We're in front of HaasTech Automation in Oxnard, California today, and today we're going to give you a tour of the demo room. I'm Brian, he's Andrew, and Andrew, let's head through these doors and take a look.
All right, let's head through the front doors here, and we're gonna head off to the right towards the demo room. As you can see, we got several trophy cases from all the different various race car wins we've got. Driver's suits, helmets, memorabilia, of course. But here we go into the demo room. You can see the sign there, and you're gonna start us off, right, Brian?
I'm gonna get rolling. The first thing as you walk through the doors, you can't help but notice a car. So why do we have a race car in the demo room? Well, this is the car driven by Kurt Busch in March of 2014, and it was his first win as a member of Stewart Haas Racing. And as you can probably see, this car is in the exact same condition as it was when it came out of Victory Lane. It's covered in, I don't know, beer, champagne, Gatorade, you name it. Pretty cool accomplishment, and we haven't even touched it. We literally rolled it right in here. Right behind me, this is kind of the star of the show. This is the very first machine ever built by Haas Automation. If you've ever seen our mill names, VF1, VF2, VF3, etc., this is the VF1. And that name comes from, remember, we had no marketing department back in the day. VF1 stands for very first one. Back in 1988, the goal was to build and sell a machine for under $50,000. And that's exactly what Gene and his team accomplished. This went to IMTS in 1988. We had a couple of folding tables and one machine. We sold a whole bunch of machines. It still runs. I'm not going to turn it on today, but the thing still operates. You can also see, really before even the first machine, the way Haas Automation started is Gene started making rotary indexers. Put a stepper motor on an indexer, and instead of indexing that thing manually, now you had a powered indexer. Also in here, we sold our 200,000th machine a few years ago, and the customer was so appreciative. They have many Haas machines. It was a UMC 750 that they made this and actually presented it to Gene at IMTS. So pretty cool piece of memorabilia here.
All right, so we're going to go from one of our oldest machines to perhaps one of our newest offerings. As you can see, this is our small footprint ST10 turning center that's married up to what we call the HaasTech robot package. And this is the smallest robot that we're offering right now. It's got a 7-kilogram payload, 6-axis robot, and what's really kind of amazing about this assembly is that for the same price that we were asking for that VF1 initially at $50K, you get this entire robot package for $50,000. That gives you this safety enclosure on the outside. The robot, of course, itself, it comes standard with a single gripper. There's also an option for a dual gripper. The base, all the mounting hardware, the robot controller. But what's really kind of the most important and the most useful for an operator or an owner is that this thing is plug and play, ready to go. There's no robot integrator needed or anything like that. And the beauty of it is when it comes time to programming the robot, all of that is handled through the HaasTech control. We use a series of menus in our familiar VPS system, and through those menus, you control the programming of the robot, and you also jog the robot with our remote jog handle, which has been updated to control the robot. So just a fantastic package and a really easy entry into the world of automation. Moving on, let's go over here to this VF2 SSYT. The VF2, of course, is one of our best sellers, our small footprint VMC. But this is the Super Speed Y variation. Super Speed, of course, gives you faster rapids and cutting speeds, 1,400 inch per minute rapids, 12K spindle, 30 pocket Super Speed tool changer, and then in this case, the Y option gives you additional Y-axis travel for a deeper work envelope this way. All right, that pretty much wraps it up here for the VF2 SSYT. Let's throw it over to Brian.
All right, as Andrew said, right next to the VF2 SSYT, we've got the DT1. Now, DT stands for drill tap. This is a super fast little machine, 2,400 inch per minute rapids, tool change in under a second, but it's got great milling capability too. It's got a 15 horsepower spindle. Speaking of spindles, 10,000 RPM is standard. We've got 12, 15, and 20K optional. So if you're drilling a lot of small holes and you want that high RPM, you can get it with this machine. Now on the table here, we've got a real fast 2-axis rotary. This is what we call our TRT 100. So DT1 with the TRT 100, you have full simultaneous 5-axis or just 3+2 capability. Now we're gonna move from the DT1 just to the right here to the UMC 500 SS. So this happens to be an SS, a super speed, but we have the non-SS as well. This is the smallest of the UMC family. So this is the UMC 500. We also have the UMC 750, and then the big boy is the UMC 1000. Now the nice thing, the great thing about the UMC 500 is its size. It's a compact footprint, similar in size to a VF2. So if you have a small shop, but you're wanting 5-axis capability, this machine will fit in your shop. And the cool thing about it, as you can see here with this low door, is you have great access. So if you're loading and unloading parts, it's easy in this machine. Now, as we come around to the side, we've got a big side window here. And the reason this is designed in is we'll have the ability to add either an APL, an auto parts loader, or even a pallet pool to this machine. So lots of capabilities with all our UMCs. Now we're going to move just to my left, and Andrew's on the VF3YT50.
As Brian was saying, VF3YT. Now what's special about this machine, it's of course our medium footprint VMC. But in here you see, we're kind of the star of the show here, 50 taper spindle. If you're doing lots of hogging, but you want to do that in a space that doesn't take as much as one of our really big ones like a VF8 or a VF10 or something. If you don't need quite that much table space and travel, then this fits the bill. 50 taper spindle, 30 pocket, 50 taper tool changer. Really, if you're getting to do some hogging, but you need to do it in a smaller space, this is the machine for you. Moving on, let's go to this one here. So this is our new long bed ST30. ST30 LY, Y-axis lathe in this case. And of course, you're gonna buy this machine because you need to turn long parts, or maybe you need to turn intermediate length parts, and maybe you want to do that with our steady rest. So you're kind of in one of two situations here. Either you're gonna run a really long part in which you're going to support it by the tailstock, or maybe you've got an intermediate length part that you're going to support with your steady rest for doing deep hole drilling and end work on that shaft. Very easy to move the steady rest back and forth. But another cool thing is, let's say I've got this little part in here. Now, if I've got a part like this, this experience is pretty much just like running a regular ST30. If I'm running a short part, this is going to be the same as when I'm running an ST30, so that's really nice. Another cool feature about this machine is you can see this hole here, if you will. This is what we call the extended Z pocket, and this gives you a lot of clearance for boring bars and other really long tools, so that you can still get all the way up here to turn on the face of your part, and you're not gonna hit those tools against the bulkhead here. So ST30 long bed, great machine. Let's move on over here to this to the APL. Now this is another example of how to put automation to work in your shop for a really reasonable price. Here we're marrying our automatic parts loader up to the ST15Y. So you've got Y-axis capability on this small footprint lathe, and then you're gonna auto feed those parts, auto load those parts here from this table using this arm, and kind of like the robot allows you to. In fact, our programming process is very similar to how it works on the robot. It really started with the APLs. All of that is controlled from within the HaasTech control here. So you use a series of VPS templates. It just walks you through. I've got these GIFs on screen here to show you what you need to do. And then to jog the machine, you're going to use the remote jog handle, in this case, our new touchscreen one. So it's very easy to move the APL arm into the position that you want to program, turn on APL mode, and the thing works automatically. If you don't need it to work in that mode, you just turn that off and use it like a regular lathe. Pretty straightforward. Let's throw it back to Brian.
All right, now we're at the CM1. CM stands for compact mill, and you can see why. Small little machine. This is an ISO 20 spindle, 30,000 RPM standard with a 50,000 RPM optional. So obviously when you have small tools, you need that higher RPM. This machine has it. Automatic tool changer, and this is primarily medical, dental, aerospace, somebody doing some prototyping. Great little machine. Obviously it'll fit in a small space, and the cool thing about this is this can run on single phase power. So if you're thinking about putting this in a medical or a dental office, you don't need 3-phase power. Okay, right next to the CM1, we've got the mill version of the APL. So the same great programming method that Andrew talked about. Everything's programmed through the HaasTech control using VPS templates, the remote jog handle. Little different configuration. We've got the 2 grippers, one for loading and one for unloading. Same great programming features. And we've also got an air vise provision in here. So obviously when you're running unattended, you're not going to be opening and closing the doors. Auto door, air vise, complete unattended operation. We're going to move to my left, toss it back to Andrew, and he's going to talk about the TM1.
Alrighty, TM1P. Now, the TM1 and the TL1 are machines that are equally at home in a production environment, or maybe more in a school environment, or kind of a inside your garage kind of environment. Really what these machines are about is introducing CNC machines to someone who's coming from a manual machine background. If we see here, this has got the table and the layout very similar to an email, Bridgeport style machine. But this is a true full CNC machine. In this case, this is the TM1P is kind of the slightly improved version of the TM1. TM1 comes at about $31,000. This is $35,000, and for that extra $4,000, you get a lot of bang for the buck. You've got a 10 pocket tool changer, a faster 6,000 RPM spindle. It's really, this kind of takes it from a more manually oriented kind of experience to really a full production CNC machine. This is just a step away from our VF2 style of VMCs. All right, let's move over to the TL1. This is kind of the same concept here. If you're coming from a manually controlled lathe, then this layout's gonna be very familiar. Chuck's right here, steady rest, cross slide. The basic version of this machine comes with a single tool post here. But in this case, we've got several options of this machine. We've got the E-hand wheels is what we call them. This is kind of a manual method for jogging these axes around. You can see here, I can jog these very much how you would on a manual machine, but you can also run this in full CNC mode. And that's the beauty of it. If you want to approach it from a manual perspective, that's easy. And also, when you're ready to move on to controlling it via CNC, it works great that way as well. And you've got the same style of VPS templates here. I can do a whole bunch of different kinds of features here. All I have to do is enter the important aspects of my part geometry into one of these templates here, and the VPS templates will output a complete program, and I can run that. No need to know G-code to start with. So, TM1, TL1, both aimed at getting a manual machine operator used to using a CNC. Let's throw it back to Brian here on the CL1.
Okay, I'm at the CL1. I talked about the CM1 earlier, the compact mill. CL1 stands for compact lathe. And again, you can see why this machine also can run on single phase power, so that's important if you're running in a small shop or a garage or if you're a beginner. But this machine has a lot of fully production features. So let's come under the hood here. First of all, this machine comes standard with an 8-station turret. And in this case, this machine has a couple of really cool features. We've got a little parts catcher here, and we've even got live tooling. So you can add a bar feeder. So we've got 2 different lengths of bar feeders. So if you add a bar feeder, you put the live tooling and a parts catcher on here, you can run this thing fully in production mode. Of course, you can also run it as a chucker lathe and make small parts. Okay, let's go right next door here. And this is what we call the desktop mill. Let me open this guy up here. So this is a fully functional CNC mill. And the great thing about it is, even though it's limited on travels, it's not really a metal cutting machine. It's designed for wood, machinable wax, things of that nature, plastic maybe. It is a full CNC machine in the sense that this is not a simulator like you're used to a HaasTech simulator. This is actually a full-blown control. So if you learn how to program this desktop mill, this same programming applies to a VF2, a DT1, a UMC, any of the machines that we've shown you here. So really geared for beginners and in particular schools.
Thanks guys for joining us on this tour of the demo room. We've looked at small machines, large machines,
all the way up to 5-axis machines, a 50 taper,
robot package,
everything in between. So we're going to do more of these factory spotlights. We appreciate you watching, and join us next time for some more of the HaasTech Factory.
Thanks.
Hi guys, I'm Marcus Imes. Thanks for tuning in again. I want to show you around one of our most popular new products, the desktop mill. It's our most compact and economical way to learn the HaasTech control and 3-axis CNC programming. We designed the desktop mill to be the next step up from the HaasTech control simulator as a training tool. Although the control looks like a simulator, it's actually the exact same full-featured control you'd find on any of our other machines, like the VF2 over here. I want to show you how easy it is to set up the desktop mill and use VPS conversational programming to generate some code. So you can see here, I have a couple blocks of plastic on the table to work with. We mostly recommend cutting plastic or machinable wax on this machine since the material is cheap and reduces damage if a crash occurs. Or, for the ultimate in simplicity, we offer the spring-loaded pen attachment which mounts directly in the spindle. Then you can put a clipboard and a piece of paper on the table and use the desktop mill to draw shapes with CNC code. But today, we're going to make some chips. So, I have my 1/8 inch 3-flute end mill, and I'll tighten this in the spindle. I should mention the spindle has a permanent female ER11 collet interface for the spindle nose, so you'll need a set of ER11 collets for each machine. Now, I'll tighten my tool in the spindle. It's a small tool, so don't over-tighten it. Next, we need to give the machine some Z geometry. So, we'll set our Z-axis offset to the top of the stock to establish my Z height. I have a piece of paper here we'll use as a shim to pinch between the tool and the workpiece. Now that I've made contact between the tool and my workpiece, I'll use this as my work offset for my tool. Now, I'm going to set my work offset. I'm going to hand jog the spindle to where I want to set X0, Y0, and then set my G54 work offset. So let's do that. Move up Z a little bit. And I'm just going to eyeball this, but if you wanted to be more accurate, you could use an edge finder as well. So I'm going to set my X0, Y0 where I'm at right now. I'll go over to my offset page. From the offset, I'll hit F4. And in this case, looks like we already have some numbers in G54, G55, so I'm going to use work offset G56. I'll push part 0 set for X and again for Y. And I'm going to leave Z blank, although on most of our machines you would set a Z work offset. Here, all of my Z geometry comes from my tool, since there's no tool changer on this machine. Now that I have my X, Y, and Z established, let's go to VPS and make a short program. You can find VPS under the Edit button, then tab up to the top and over to VPS, and then go down to the VPS, and we'll go over. As you can see here, you have a few different shapes we can easily make, like bosses, pockets, drill patterns, but today I think we'll do a little engraving. So let's see what it takes to operate one of the VPS templates. These are all composed in a very similar manner, and basically you're just answering questions from top to bottom. We have useful pictures that help determine what inputs we're looking for, and we have some help text down here. So the first thing it's asking for is our work offset. By default it chooses G54, but if you remember, I set G56. So I'm going to enter 56 and enter button, and now we're using offset G56. Next, it's asking for a tool number. I can tell we are currently using tool 2 from the offset table, or from the memory screen, it also tells me tool 2 is currently active. I'm going to leave that alone since we don't have a tool changer, so 2 is a good number. Now it's asking for my spindle speed. How fast do we want the cutter to turn? I have a valid range of 50 to 24,000, so quite a bit of range in there. I'm going to choose 5,000 RPM just from my experience, and I know that that won't be too fast for this machine. Since we don't have coolant, I don't want to melt the plastic, so I'm going to select 5,000 and press enter. Next, I need to give it a feed rate. How fast do we want to move? Well, how do we calculate that? Since I selected 5,000 RPM, and I know my end mill has 3 flutes, and I know a good chip load for this plastic material is 2 thousandths per flute, I take 15,000 times 0.002, which would give me 30 inch per minute. So I'm going to enter 30 with a decimal, because this one requires a decimal. Next, M8 is asking coolant or no coolant. This is a code all new machinists will learn very early on. And this is one way that VPS reinforces codes where applicable. So if you're choosing a canned cycle or like coolant on, coolant off, we're going to reinforce that with the actual M or G code in the template. In this case, we don't have coolant, so I'm going to enter 0. Now it's saying, where do I want to start? Since I positioned my G56X0 at the position that I want to start engraving, I'm going to leave this one as 0. But I am going to move Y up about 100 thousandths to get us off the center line of the part. So I'm going to enter 0.1. Now here is my rapid plane. The rapid plane is where the tool changes from G0 rapid approach to a G1 feed move. The default we have in there is 100 thousandths of an inch. I'm going to leave that alone because that's a pretty industry standard number. Now it's asking for my Z depth. How deep do I want to cut? I know that this plastic top, the red plastic on the top of this part, is 50 thousandths deep. So I'm going to say give it a value of maybe 70 thousandths, so we cut down below into the white. Now we can do either text or serial number or a specific number if we wanted to do that. In this case, I'm going to leave it 0 to select text. And we could, it's asking how high do I want it. A ½ inch looks good to me. And do I want it on an angle? In this case, no, I'm going to go straight across, but you could also do it at any angle around the circle. And now at the bottom, what do we want to engrave? How about HaasTechnology CNC? And that's the last line of this template. So from here, we can do a couple things with it. If you notice up here, we have generate code with F4. So we can copy it to the clipboard if we wanted to paste this into a program. I can output it to MDI, or I can create a new program with it if I don't already have one established. In this case, I'm actually going to use the fourth option, which is just pushing cycle start, and that will run the template directly from this page. But before I do that, I'm going to move my machine away from the stock a little bit. In case I entered any bad numbers, I want some time to push stop. So let's do that. So first thing I'm going to do is move Z away from the table a little bit, just in case I got anything wrong. This will give me some time to realize that and stop it before I crash anything. So I'll go back to my VPS template. I'm going to change my rapid down to 5%, and I'll hit cycle start. Once I'm confident it's moving in the right direction, I can change that rapid override to a higher value. Now since the desktop mill doesn't have a tool changer, the first thing it's going to do is move to the back corner to a safe position and ask me if the right tool is loaded in the spindle. This way you can make a program with multiple tools even without a tool changer. But since we already have the tool in the spindle, per the message on the screen, I'm going to push the letter K to continue. And now I'm going to change the rapid override down a little slower. Now that we're moving in the right direction, it looks like. Speed it up a little bit. And just to make sure I got all my heights correct, I'm going to stop it just before it gets to the material and look at my distance to go screen. So I'm going to press position and then tab over to distance to go. I see I have 49 thousandths, which looks about right. If that number was drastically different, that's your first warning that something is wrong and you should stop and double check everything you've done. Now that I've verified my distance to go is good, I'll press cycle start and continue. I think you can see why there's a lot of excitement around the desktop mill. It takes a full-size machine's capabilities and shrinks it down to about the size of a mini fridge, but still allows hands-on setup, programming, and troubleshooting experience, which directly translate to our full-size machines. Check out HaasCNC.com to get a custom quote on your own desktop mill with our build and price tool today.
Good morning, guys. We're here in Oxnard, California, at the HaasTech factory, and today we're going to give you a tour of pretty much the whole facility. So let's go in through the front entrance here and get started. All right, so this is the main entrance, of course, the lobby here. Now we've got racing memorabilia on each side from all of HaasTech's race teams, but we're not going to look at that right now. Demo room's over there. We've got another video that covers that. Right now, we're headed towards the machine shop. We're here in building 1, of course. We've got 4 buildings on campus here, totaling over 1 million square feet under roof. And we're going to start in building 1 on the machine shop side, as I just said. Right here, actually we're on the other side of this wall, is rotary assembly. We'll be coming back to that quite a bit later here in the video. Right now, we're headed towards the machine shop side of building 1, and this is where we house a lot of our FMS systems. So, building 1, machine shop side. As you can see here, we've got some rotary table bodies that are surrounded by them actually. HRT 1000, our largest rotary table. TRT, rotary bodies, and trunnion castings. HRT 310s, 210s, 160s, runs the whole gamut. But on this left side here, this is kind of what we're going to focus on for right now. All throughout the factory here, we have a variety of different FMS cells, or flexible manufacturing systems is the long name for them. Right here we've got these machinos, several machino cells tended by these pallet walls here. And really this just signifies HaasTech's investment in the right tool for the job. We've been using large FMS cells since before I started in 1997. So the concept and reasons are well founded. But we continue to make new investments in these systems because it's the right approach in some cases. People ask, why aren't you using HaasTech machines throughout your entire factory? And the simple answer is, these large HMCs and pallet stackers are not the market segment that HaasTech is building machines for. But it is the right tool for the job in this case. A high mix of parts at a medium volume makes these pallet stackers ideal. The concept is simple really. Machine the right part at the right time here in the machine shop so that part is ready to put together on the assembly side of the factory when it's needed. And keep these spindles turning as much as possible. All right, so we're leaving this, the Makino FMS cells. We've also got some Japanese ones down that way. We'll probably see those on the B-roll. Anyway, you can see we got lathe turrets here. Rounding the corner, we're gonna head down this aisle here where we've got a whole line of EC400s. Now these are our earlier version, not the present one. Most of these machines were installed between 2012 and 2014, so 6 to 8+ years old. Now, this is kind of an example, well, this is completely an example of how HaasTech does the same style of machine as those FMS systems we just looked at. But in this case, it's geared towards a medium-sized shop at a much more affordable price level. But the idea here is that these horizontals are aimed at getting a high mixture of parts, or maybe you're focused on one specific part. All of these cells are mostly concentrate on 1 or 2 parts or a few parts where we're doing very high volumes. But you can see, when you attach a pallet pool like this to one of these HMCs, you've got a lot of fixture positions. And the idea is, with the pallet pool loading and the pallet changer loading those pallets in and out of the machine continuously, your spindle on time is maximized. You can see right here, we're making motor housings for our machines. Just one example of all the different parts we make on this line here. All right, so we're right next door to where we just looked at those EC400s. Now you can see we've got this line of BMC 1000s. These replaced older models just recently, but the idea is the same here, just from much larger parts. Each one of these machines has 10 pallets, and you can see we've got a variety of different castings. We've got saddles, bases, just a huge part mix, but on these huge 1,000mm pallets, the focus is large parts, of course. All right, moving on from those FMS cells, this is one of our 2 cylindrical grind areas. We've got kind of a variety of robot-loaded and manually loaded cylindrical grinders. And you can see right here, we've got a robot tending this Studer grinder. They do spindle shafts, of course, all the different kinds of shafts, transmission shafts. As you can see here, we've got a large variety of different output shafts, transmission shafts. Anyway, let's head around here. More cylindrical grinders. And then right past these machines here are our gear hoppers, and we'll take a look at that in a minute. But let's head this way. Over here, we have this giant, this is our newest gear hopper here, this giant modal gear hopper. And we bought this primarily to focus on the largest rotary gear sets that we make. Now you peek in here right now, this is an HRT 310 gear, if you want to take a look in there. But really, this is focused on HRT 600, 800, and 1000 rotary table gears. So really large gear sets. Anyway, huge gear hopper. Now over here on this side, we've got really the bread and the butter of the gear hoppers here. These focus on HRT 160, 210, 310, and up gear sets. And the thing here is, these are, we've got millions of dollars of machinery here, but it's not just the machines. You can't put these into your shop and expect to be making high precision gears that fit perfectly and yield really good rotary accuracy, a week later. You also have to have the crew of professionals that have all the wisdom and the knowledge to make those machines run correctly. And that's what we've got here. All right, this is our inspection room here, considerably quieter than the rest of the factory. This is just another example of HaasTech's commitment to quality. We've got a huge variety of measuring tools in here, but probably you'd say the star of the show are all the different CMMs we've got here. This largest one is 3 by 1.5 by 1.5 meters. We use this for measuring our largest castings. We have a variety of other measuring tools. We do something like 15,000 tools that we calibrate every year, gear checkers. Anyway, all kinds of cool stuff in here. Well, let's head this way for now. All right, so here we're sitting in front of these giant MPCs, focused, of course, on huge parts. We've got UMC bases behind us, big SD50 base here. Anyway, you can see that these are pallet-fed machines as well. You can load your part here. You can load your part here while you have another batch of parts running on the machine. So it's kind of the same idea as the other FMS systems, just for much more massive parts. All right, we're just leaving the machine shop side of building 1. So we've just done one half of building 1. We got a long way to go. But out here, it's kind of an example of, just the basic infrastructure of the factory. You can see here we've got compressors, and we're looking at about 650 horsepower, something like 2,700 CFM of airflow. That's quite a bit more than your standard shop. Past that, we've got our coolant recycling area, and on average, we're recycling about 3,000 gallons of coolant every month. We evaporate the water and then recycle all the used oil, of course. Also here you can see our propane area. This is where we have all the propane tanks to fill up the 200 or more forklifts we have driving all over this place. And then you can see these castings here. Anything that's marked with red like these are our first article castings coming in from inspection from our casting vendors all over the country and all over the world. So let's keep moving. We're gonna go head on over to building 2 to look at some more of our machine shop. All right, so we just walked into building 2, and this is of course the machine shop side of building 2. In fact, all of building 2 is pretty much machine shop now. Behind us are, of course, more FMS cells, and really it's the same story. We use these to build a high mix of different parts. On this side, these machines are mostly concentrating on aluminum these days. But the idea here is that overall in this machine shop, we have about 60 machines dedicated in FMS cells and over 1,000 pallets. So I don't know if it's the biggest in the world or in this country, but it's huge to say the least. All right, so we've left the area with the FMS systems. Now we're back over in another area devoted to really large machines. This right here, this VB3 from 2005, I think it is, you can see is still being used. Right now we've got an EC 1600 table sitting on here. They've got a rotary control box hooked up to it. Not sure what they're doing, but they do kind of one-off stuff on that machine from time to time. And then right here we have more of the older MPC double column machines, focused of course on the largest castings. These have been here for a long time, but still chugging away. And then on this side, we've got these Akuma MCRs. This is just essentially a newer, a little bit more sophisticated, quicker version of the same thing. All of these machines, of course, are pallet fed. So you've got a part waiting to go. You've got your part being machined, and then as soon as it's done, it moves out of the way and you load another one, so you're maximizing spindle on time. All right, this is gonna be the last FMS that we'll look at today. This here is one of the largest FMS systems in the entire world based on the number of load stations and the linear number of pallets involved. Here we've got a really large mix of parts. You can see all the castings up there on the pallet wall. Lathe spindle heads, lathe gearbox housings, tailstock housings, just a really wide variety of parts, all made basically just in time for the production line. So now we're entering an area that's filled completely with HaasTech machines. As you can see on this side, we've got one of our robot cells. This cell is dedicated to building columns, just VF1, VF2 columns, very high volume. In here we've got 4 of these cells with E1600s tended by robots. We're building columns over here, tables and saddles over here, saddles over here, saddles there as well. So these cells are all dedicated to making 1 or 2 parts at very high volumes. These are machines responsible for keeping our small and medium VF casting lines running continuously at really high volumes. So now let's head on to this side. So all of these cells use 260 EC1600s manned by a robot in the middle. On this side, we have a different configuration. This is typical of our other kind of robot cell. Here we're usually looking at 2 lathes and a mill tended by a robot in the middle. These are mostly focused, of course, on making round parts, spindle shafts, a variety of round other flat parts. So this cell here is an example of one that's dedicated to just 1 part. These are 40 taper spindle housings, of course. We go through a whole bunch of these every day, probably upwards of 50 of these a day right now. So this cell is dedicated just to making those. Now let's head back this way. We're gonna take a look at what we call our batch production area. And that's just a big group of HaasTech machines dedicated to making a whole variety of different parts, mostly on the mostly smaller parts, turned and milled parts. Let's head over here. So this is what we call the batch production area. This is really the area of our shop that's the closest to a regular job shop. We've got a variety of mills and lathes. This particular area is a little bit near and dear to my heart because back in another lifetime here when I was a manufacturing engineer, these 4, actually most of these machines here, but these particular super speed VF2s, a little bit older, these are all around 2008 we put these into place. And at that point I was the guy that was responsible for doing the factory floor layout, making sure these machines came into place and older ones got moved out in their place. But you can see here we've got a testament to how long these things run. These have all been here for 11, 12 years or so, running non-stop. So let's head back out of here. And just like a job shop, this area is really focused on doing shorter runs of parts, stuff that the line needs right now. Now we're gonna head from here and we're gonna actually finally leave the machine shop and we're gonna head towards assembly. Okay, so on the left here we have electrical assembly. And we've pretty much divided this area up into two different distinct areas. This is the control cabinet assembly on this side, and then over the wall, we've got electrical sub-assemblies. But here you can see control cabinets that are partially assembled. Here's one we're looking at. We got our vector drive, the amplifiers for the various axes, main con board, I/O board, all that good stuff. Here's where the incoming power comes in. So we test these here, of course, as soon as they get powered up. And then when we get to the assembly line, when we put those control cabinets on the machines, we test them again there from the point at which you're doing the squaring, as soon as you can move the axes, all the way through till final assembly when we're doing the test cut and all that sort of stuff. Okay, so we're leaving electrical assembly. Now we're getting into the actual assembly area where we put the machines together. On this side, we've got large VMCs, and on this side, we've got UMC assembly. We call these the cast assembly areas. This is where we put the foundation of the machine together. If you look at this VMC, for example, right here, you can see we've got the base, saddle, table, column, spindle head, and we put these machines together all in quite a similar way, really. It's what we call the stacked axis method. It's pretty simple, really. We start with the base on the ground, lay down the linear guides, then the saddle, then the table. Typically, we build the column offline separately. We'll put down the linear guides and ball screws there, and then we'll attach the spindle head to that, and then we'll lift that column assembly and put it onto the base. And there you've got your entire basic machine assembly ready to go. Then from that point, it leaves this casting assembly area here, and we move on to what we call the final area. So this is the UMC final area. A few years ago, it was only the UMC 750. We've got one of those right here, of course. But these days, we've got the smaller brother and the larger brother to the 750. That's probably UMC 500 right here. See, just a little bit smaller, small footprint. Moving from that to the biggest one we're offering now, this is the brand new UMC 1500 Duo, in this case an SS version. Here we've got the trunnion rotary table and a VF2 table. So you've got two complete different work envelopes you can take care of. Lots of possibilities here. Let's go across the aisle. Now we've got, over on this side, we've got UMC 1000 SS. So the super speed big brother to the 750 and the 500 right here. So of course, when we come to the final line, the idea here is after the casting assembly is done, here in the final line, we take care of the geometry of the machine, aligning all the axes. Then we put on the sheet metal, install the control, and then do all of the testing that goes into making sure that the machine is ready to go. Okay, so leaving the UMC area, now we're entering where we build all of our EC machines. This is our brand new EC500 50 taper. And we're gonna be looking at this later in the show, but brand new machine, just released. This, I believe, is the first one. Right beside it here is one of our EC400s, pretty much in the same stage as those other machines we saw. Here we build these machines all in one spot. We don't have a casting area and then a final area because the production levels are lower, and since they're even larger, we typically like to just leave them in one spot and bring the sheet metal to them as we assemble them. Now let's walk through. This is where we build our GR gantry routers and our GM gantry mills. You can see this right here, GM2 5AX. Got this 5-axis head on here. This has got the extended Z travel. Super capable machine for doing really large 5-axis parts. So now let's go leave this GR area and we're gonna walk straight back over here. So now we're in the VMC, large VMC final area. And this machine is an example of one that's in the middle of getting the geometry checked. It's kind of the same for all these different lines. You get this machine out of the casting area and you're gonna line up all the different geometry of the different axes, make sure everything is square, perpendicular. And then from there, you're gonna start installing the sheet metal, and then it goes through the whole plethora of different tests leading up to the final test cut. Most of these, you can see we have some machines that are enclosed down there getting ready to be test cut. So these cells here are an example of how we do kind of medium volume, medium sized castings and keep the spindles turning as much as possible. Here we've married up, we've got a whole bunch, like 7 of these cells, and typically it's a VS3 married up to one of these Midaco pallet changers. So here's the pallet changer, and up here, of course, is where the machining is happening. So we've kind of run 2 different things here. Medium-sized lathe bases, small lathe bases, and then on some of the other cells we run medium and small VMC castings. So let's go walk down this aisleway here. So we've been running these VS3 cells for easily more than a decade here. But more recently, we've teamed those up with these Midaco pallet changers. And it's the same idea as we see on even the FMS systems and any of the EC400s. You're carrying multiple parts so that you can keep the spindle turning the entire time. You've got one part staged, one part being machined, so you keep that spindle turning. Let's go through here. We can see more of these pallet changers. Here we are where we're getting ready to load these small VF bases onto here so that machine will run those. Now let's leave this area here. Got one more thing I want to show you before we leave this building. Here we have 2 cells dedicated to making just the side mount tool changer cams. And we used to have EC630s that were custom modified, making these castings. So quite a sophisticated machine. And these are sophisticated, but it's kind of a more simplistic approach. If I come in here, you can see this is just a VF3 with a customized TRT 210 rotary table on here. It's just essentially an offset platter mounting, and these cells are dedicated to cranking these cams out all day long, every day. Got another one right over here, and that's just because we make a lot of tool changers every day. let's head this way. We're going to take a quick walk through the casting yard here. Okay, so we're entering the casting yard here, as we call it. This is a favorite for when we're doing real live tours, of course. Now, this is where we hold the bulk of our castings before they get machined. As you can see, we've got castings on every side. Large VMC columns over there. Small, medium bases here. Let's keep walking this way. More medium base castings here. We're looking at around 7 million pounds a month right now. 350,000 some odd pounds of cast iron machined every day here. We get our castings from pretty much all over the world. USA, Canada, China, Thailand, India, Poland, and all of those castings go through the same rigorous inspection here. They all have to meet the same specifications no matter where they're coming from. So as long as they meet the specifications, we're good to go. Here are some, some more similar castings. We have UMC castings back there, UMC 750 castings. Here we have EC400 base, runs the gamut really. And what's crazy is that all these castings here, this is about a 1 month supply. We'll turn all of these castings, or pretty much all of these castings, over every month. So it's a huge amount of cast iron we're talking about. Let's keep walking through here, and we're gonna head to building 4, our inventory building, and take a look at the huge pallet racks and the narrow aisle equipment over there. Let's head this way. So this is building 4. This building houses all of the inventory for the entire factory. So in a second, we're going to see all the inventory racks. But right here, you can see we're actually doing assembly work here. This particular line is dedicated to small and medium enclosure assembly for the VMC line. It's our highest volume line. So we put them together here, roll them over to building 1, just a more efficient way to put together these large enclosures. Let's keep going this way. Now we've got kind of a mix of regular width aisles here, and then as we'll see in a second, we also have narrow aisle equipment, just to get more density, of course. We want to store as many parts as possible. We store literally tons of sheet metal here. Sheet metal is really the biggest space hogs, if you will. So we store a bunch of it here. In front of us here is where all the incoming inventory is handled. We typically fill and then clear this area 3 times a day. We've got some nearly 700 vendors worldwide, so all of that inventory is coming in onto this dock and then disseminated into these pallet racks every day. So in this building, we've got 34-foot high ceilings, 10 feet higher than any of the other buildings in the complex. We have precision flat floors with guidelines in the floor for use by the narrow aisle fork trucks. When we were putting this building up, we used 1.5 million pounds of pallet racking, and that gave us 17,000 pallet spaces. We have more than 20,000 different part numbers in this area and over $50 million in inventory. Typically, we're looking at about $1.5 million a day coming in from our various suppliers all over the world. As I said before, we're somewhere around 675 suppliers worldwide. We're looking at typical inventory levels of 10,000 ball screws and 30,000 linear guides at any time. We stock components from THK, NSK, Bosch, ENA, Steinmeier, and SKF. Our total consumption of these 2 critical parts is around 33,000 ball screws and about 87,000 linear guides every year. So this is the service parts shipping area here in the factory. This is kind of on one side of building 4 here. You can see these are all orders going out to our dealers. We hold about $10 million in stock here, and that's in addition to the $75 million or so that are held in all the HFO consignment stocks around the whole world. The idea is for dealers to ship service parts from their warehouses or to have those actually in the service vans that are going to the customer shops. But whenever that isn't the case, we're shipping those parts next day from here. And typically, we're maintaining a 99% same-day shipment. And if you go to our service webpage and you page down a little bit, you'll see that we actually post what we're maintaining service percentage shipment-wise every day. And typically, we're above 99%. Pretty amazing. That means that if a customer needs a part, they're gonna get it as soon as possible. So we're headed back towards building 1. We're going to end up finishing up on the building 1 assembly side of things. Just left building 4. But I just wanted to mention here, this is what we call our freight consolidation area. Most of these machines are headed overseas, but sometimes we even gather together larger shipments that are headed to the US. But the idea here is large groups of machines all headed to the same HFO that we want to group together in one shipment. So we've got machines staged here going all over the world. Who knows? Maybe one of these machines is headed towards your region now. But for now, let's head back to building 1. We're going to take a look at assembly. All right, now we're back at the very front of building 1. Actually on the other side of the wall where we first walked in at the beginning of this tour. Now, this is the rotary assembly department. Rotary tables and indexers, of course, is where Haas got its start. Nowadays, we're surrounded by a lot more than just the basic indexers and rotary tables. We can see TRTs on this side, trunnions on this side. Here's some more of the typical stuff, HRT 310, HRT 210s and 160s. If we keep going this way, here we have a whole bunch of rotary tables getting ready for shipment. And it's easy to see why Haas Automation is the market leader in rotary tables and indexers. All right, so we're coming from rotary assembly into VMC assembly, and that's probably fitting because that's basically the progression that Haas followed from rotary tables to vertical machining centers. So this is the cast assembly area, and this is actually this assembly line, what we call a flow line. We just put it in place recently. Really, this is just a more efficient way and maybe a little more consistent way to put together VMC columns. In this case, small columns. This is our highest volume column assembly that we make here. You can see that this is kitted, ready to go, so that once it's assembled here, it's taken over to this side. This is where we do the entire stacked axis method we were talking about earlier. We place the base on the ground, add the linear guides and ball screws, install the saddle and table, and then we take that column assembly that we built over here, lift it with a crane, drop it onto the top of this guy here, and you essentially have the bare bones of the machine. Then we take this finished bare bones machine here, and we take it across the aisle, and we head into what we call final assembly. And here, we finish the geometrical alignment of the machine, make sure all the axes are square and everything, perpendicular, and then we start installing sheet metal. You can see these machines here. This machine, of course, is just about ready to ship. You can see most of these machines are getting ready for shipment. In fact, this one's being cleaned up, prepared for shipment. This will probably be going out later today. Now, we're going to keep going. We're going to leave VMC assembly and head towards lathe assembly. Okay, so we've left VMC assembly. Now we're entering the lathe assembly area. As you can see right here, we have some assemblies that are getting ready to be put on this line. Wedge assembly here with the turret attached, all ready to go. Over on this side, we have spindle heads ready to go on the line. Another wedge assembly. Now, over to my right-hand side here, this is where we put together the small lathes, ST20s. And then over on my left-hand side, this is where we put together the ST30s. Now, similar to the mill line, we have a cast area and a final assembly area. This is the cast assembly area. Kind of the same idea here. You place the base on the ground, put down the linear guides and ball screws, and then you start adding all the large sub-assemblies. In this case, let's get back to this one here. Now you see here, we have a base casting where no assembly work has been done yet. Just getting ready, they'll level this out, then they're ready to put on the ball screws and linear guides. Right here we have an assembly that's progressed along a little bit farther. This is the bare bones spindle head right here. Here's our wedge assembly and the turret, tailstock. These are kind of all the main components that need to be on this lathe to turn into a functional machine. Ball screws, linear guides, everything's been installed. From this point, they're going to attach the control, and then they'll start building the sheet metal around it after they've made sure everything geometrically is moving correctly. Let's go from here down to the final line. So here we are on the lathe final line. This, of course, is the small lathes, ST20s, 25s. This ST25 is, well, looks like it's almost ready for shipment. It'll be completely final packed up in a minute here. It's running the last series of tests, just kind of exercising the control and the axis motion. Once again here, I'm beginning to sound like a broken record, but here in the final area, we put on all the sheet metal after the geometry of the machine has been set, then we install whatever options are attached to that order, test those, do a final test cut, and the machine's ready to ship. It's going to go from here out to our shipping area. Let's take one more walk and finish up in the shipping area. All right, here we are at long last at the back end of building 1. This is the shipping area here at the factory. And this is, of course, where all of those machines and all those different assembly lines end up. And they get packed for shipment to an HFO near you or a machine shop near you. We'd like to thank you for joining us on this whirlwind tour of the factory here. And we really hope that the next time you're in town, you can join us here for a real live tour. Thanks for joining us, and we'll see you next time.
Hi, my name is Milton Ramirez. I'm going to talk about the HAAS control today. The HAAS control has been designed for user friendliness over the years. Since its introduction in 1988, the HAAS control has been basically the same layout from day one. So I want to talk a little bit about that because the HAAS control is, I believe, the easiest control to learn out there in the industry. A student can come and spend a couple of hours maybe with an instructor on the control and learn how to manipulate the machine and all the basic operations fairly quickly. So basically the HAAS control is made up of sections, right? The first section I want to mention is the function keys. These are used in many different displays, many different pages, and as their names say, they have different functions assigned to each one of them. The next section is called the display section. This one allows you to navigate around the different screens or displays on the HaasTech control. Next, we have what we call the mode keys, right? It's basically 6 modes. Those are the common modes that every
Sullivan monitoring the chat. So as we go through this, we encourage you to keep entering your questions or comments, and those guys will respond to it. So this session is about HaasTooling.com, and John is our resident Haas tooling expert. We'll talk a little bit more about that in the future.
Okay.
So 2 ways you can get Haas tools. One, if you're buying a machine, you can add all the tool holders, cutting tools, pull studs, everything you need to the machine order, and package that entire thing and finance it all together. So you get a new machine, you're gonna need new tools. It's a great way to finance everything. Or you can buy direct, HaasTooling.com. I know a lot of you out there have small shops and you probably go home at night and say, oh man, I need some end mills tomorrow. Go to HaasTooling.com, order your 1/2-inch end mills. If it's $99 or more, it's free shipping and you'll have the tools in a couple of days. So John's here because John is our expert on testing. As a matter of fact, John supervised all of the mill testing.
Yeah.
So what we like to say is these tools are John Nelson approved.
Aw, shucks.
So let's talk about a little bit what you did with the testing, how you spearheaded that.
So we got all of the tools in. We set up a custom VPS template to define places for them to put the surface footage and the chip load and all the information that you would get from the manufacturer. We recorded via dprint statements to output the tool diameter, the material that we were cutting, a whole bunch of information that we all got in spreadsheets. And then your team set up video cameras inside of the machine that we were testing.
Right.
So every mill cutter that we tested, there's a cutting video that goes along with it.
That's right.
And then we were able to, using that, we programmed all of the tools to run right in the middle of the recommended speed and feed from the manufacturer, to make sure that once you got this tool and you ran it on this material, if you plugged in the middle number, it would work. I promise you it will work. Now there's plenty of room on these tools to either speed them up to make them run quicker or slow them down if your application is a little weaker. You have a long tool, long overhang, or thin wall material, whatever it is, there is room to go up and down in those in those recommended speeds and feeds. But for our testing, we put everything right in the middle. Now, not every tool we tested made the cut.
Pun intended.
yeah, literally pun intended. But most of the stuff we did was excellent, and so obviously we only chose to provide the tools that performed very well during the test.
Right. So we're going to get started on looking at some of the tools, and the way we're going to do this is we're going to start with tools that are currently on the website, and that's about 2 tables worth of tools here. Then we're going to get into the coming soon. We've got some tools that'll be on the site in October, maybe November, and then after that is the future stuff. We're going to kind of give you a sneak peek.
Yeah, 2021.
That's right. Okay, so let's get started here. We're going to start with modular and insert drills.
Yeah. So here's the modular drill. This is an example of one of them. These are tool steel bodies that take a carbide insert that goes in the tip, and here's the tool that comes with the body to install the inserts. And essentially these are for your medium-sized holes. They kind of bridge the gap between the solid carbide drills and the larger insert drills. And the cool thing about these is that you can get one drill body and put in a couple of different insert sizes, so you can drill different size holes with the same body just by changing the carbide insert. We have 8 different seats, or 8 different bodies, and available 18 different inserts that fit those. So that gives you an idea of how many different inserts are for the different bodies. So that's modular drilling. And then here we step over to, next we have the insert drills. So these insert drills are for the medium and large diameter holes. We offer these in sizes from 3/4 of an inch up to 1 3/4 of an inch. And all of these insert drills that we carry have two specific inserts that go in the drill. There's an inboard insert, or the internal insert. That's this one right here. This insert gets installed on the front, and then this insert is the periphery insert, which goes on the outside edge, or the bigger diameter. So it's really nice because they design the inserts to perform better at the periphery of this drill, and this one to perform better on the inside of the drill. So they cut fantastic and produce a really good finish, but also produce the holes very, very close to the specified size. So fantastic. And then each of the insert drill bodies comes with the Torx wrench for installation. Loosen and tighten the screws for installation. Yeah.
Okay, so we're going to move on to drills and taps, and before we do this, I want to mention real quick that these taps, obviously all the prices are on the website. If you buy 5 taps, you get a 5% discount. If you buy 10 taps or drills, or end mills for that matter, you get a 10% discount. So enough of selling, I'm going to let you actually talk about the tools.
So solid carbide drills here in the back, there's a couple of examples here. We have 29 different sizes available. And including all of the tap drill sizes for inch size threads. We offer these drills in 2 different geometries. Both geometries are talon coated. That's titanium aluminum nitride coating, which is widely recognized as the best high temperature coating for drilling applications. So the 2 styles that we have, 2 geometries, one is for steel and cast iron. The other geometry is for stainless steel, high temperature alloys, and can actually be used on aluminum. Now the drill for stainless and high temp alloys are only available in through spindle coolant because those applications really require coolant down in the cutting zone. The drills for steel and cast iron, you can get them in non-TSC and TSC versions. They're a lot more a lot more resistant to heat in those materials, so you don't necessarily need to use through spindle coolant on those carbide drills for that material.
Okay.
If we move up to the taps now, we have a variety of different taps. Let's see, the tap sizes are available in 16 different inch size ranges, and metric is coming soon, folks. We get that question all the time. But we carry them in sizes from 440 up to 5/8 11. We've also got them in 5 different coatings. There's a bright coating generally used on aluminum and non-ferrous materials. There's a hard slick coating. There's a titanium aluminum nitride, and titanium carbon nitride. So there's a variety of different geometries and coatings available on all of these. Check out the website, look up the best tap for your application. Also, we got to pay attention to whether you're going tapping a through hole or a blind hole. All of that stuff really matters. So,
okay, let's move on to end mills.
End mills, solid. Here's a range of solid carbide end mills that we carry. First, we're going to start with the 3 fluters here. We've got a 1/4 inch, 3/8, and 1/2 inch version of this to show, but we carry these in 10 sizes. Again, primarily designed to rip aluminum. In the talon coated, so all of our 4 flute and 5 flute end mills are talon coated. Titanium aluminum nitride. We carry those in a range of 15 different sizes. For the 4 fluters and 13 different sizes in the 5 fluters. There's also different cut lengths. So again, browse the website, see what we've got. Full range of general purpose sizes of end mills. Again, excellent quality. These solid carbide end mills have been running in the Haas automation shop for years and years and years. Kind of one of those things why that's how we got into distributing tooling.
Yep, we realized, hey, we've been using these for years. Why don't we sell them?
Yeah.
Yep. Okay, so we're moving on now to not just a shell mill, but actually a shell mill kit.
Yeah. So here we're looking at a 3-inch shell mill body with the inserts, and all of these shell mill bodies come with the Torx wrench and the MollyCoat lubricant to put on the screw when you install it. And I can't stress enough that when you're installing inserts, you should always be using the grease, anti-seize grease on your screws,
Unless you don't want to get them out ever.
Yeah, you'll really struggle getting them out. So anyway, they come. A tube comes in the kit with all of the shell mill holders. Now, what I wanted to show you is that now the shell mills are pretty new. It's just been a couple of weeks on the website.
The kits are just, yeah, a few weeks.
So we not only did we introduce the shell mills, but we also introduced a kit that you can buy. And I'm going to run through on the website. Frank, if you can pull up the website. I've got another computer over here, and I'll show folks. I'm on the HaasTooling.com page, and I'm going to go to milling here. And then once I'm in milling, you'll see I've got shell mill bodies, I've got milling inserts, end mills, and over here, indexable milling kits. This is what I wanted to show. With the indexable shell mill kit, there's 4 easy steps to setting up a kit. Now you get a look at each of the inserts that we offer in our shell mills, as the octagon, the square, rectangle, and so on. But you can see, so the first is to choose your style of insert, and then select your application material, select the diameter that you need, and the last piece of information we need from you is what taper tool holder do you want and how long do you want that tool holder to be. So when I get down here to the kits, I look on the left-hand side and I see the categories. So I'm going to select this HAAS rectangle insert here, and I'm going to be cutting aluminum, so I'll select that aluminum material. I want the 3-inch diameter shell mill, and I want, well, let's see, I want
to scroll less.
I want a mouse that scrolls a little smoother than this one. I want the Cat 40 2-inch gauge length tool. So you'll see that I've now narrowed my search down to the HAAS HP NP aluminum 3-inch kit. Now if I select this kit, we see that's $500. When I scroll over here, I can see everything in this picture is included with the kit, but also notice down here, I'm going to save 23% on this whole thing by buying it all together at the same time. If I purchase them separately, $648. If I buy them in the kit, $500. Fantastic deal, and it gives me everything I need except the pull stud. I just want to mention that the pull stud doesn't come with this because we don't necessarily know if you want TSC or non-TSC, but you can buy the pull studs separately. So that is putting together a shell mill kit.
Okay, and we're going to show you another shell mill kit. Frank, if you want to come back to us.
Here's another shell mill kit that I put together with a 4-inch shell mill, those rectangular inserts for steel, the 50 taper body. Again, you can see I get a box of inserts, I get the wrench and the anti-seize grease. Comes with these 2 things in the box, and that's it.
Okay, and now we just talked about pull studs, and here they are. It's almost like we planned it. So we've got 40 and 50 taper pull studs. Now we offer both through spindle coolant and non-TSC. You can get them in a box of 10, or we have something called a refresh kit, which is 100 pull studs.
Fantastic.
And I think we want to really talk about quality here, and instead of us just talking about it, what if we show everybody?
So if you can zoom in on this pull stud, I just want people to get a look at the quality of manufacture of this tool. There's no tool marks on this thing at all. It's beautiful. The grind work is awesome. These tools are such high quality, and really, like everything we offer, has been fully tested, and we've been using these pull studs in our shop for years and years and years, and really, really happy with the quality.
Good. Yeah, it's always better to show it than to talk about it. Okay, moving on. Now we have a kit. This is a 10-piece tool holder kit, and this is our most popular kit.
10-piece ER tool holder kit. It comes with 3 of the ER32 short gauge length and 1 of the longer gauge length ER32 holders. It comes with 2 of the shorter length ER25 holders and 1 of the long ones. And then the ER16, we also get 2 of the short gauge length and 1 of the longer gauge length. It comes with the wrenches for each of those different sizes. So you get these 10 tool holders, the wrenches. You get a ER16 collet kit, ER25 collet kit, ER32 collet kit, and a box of 10 pull studs for those 10 tool holders that come in the kit. Fantastic kit. Highly recommend. Very versatile because of the range of tools that you can hold with these collets in these ER tool holders.
And that's why it's the most popular kit.
Yeah.
So we're about to leave the land of these are the tools on our site now.
Yep.
To the land of these are the tools that are going to be on our site. But this is a good time to talk about something that we've just implemented called the Haas Tooling Buyers Club. And Frank, if you don't mind bringing that graphic up, please. So if you go into HaasTooling.com and scroll down a little bit, there's a banner there on the website to sign up for the Buyers Club. So the Buyers Club is a couple of things. It's the image you see on your screen right now. Every week you'll get an email and there'll be a different discount on different tools. We might have one tool, some percentage off. In this case, we have a shell mill body and a modular drill body. It changes every week. But in addition to that, and the reason I bring it up now, is we're going to tell you what is coming next on the site. So when we're about to introduce something new, you'll get notified about it. Okay, let's
I wanted to make one point too. On the website, that same HaasTooling.com page, about halfway down, you'll see, I believe it's Contact Us.
That's a good point, yeah.
I can pull it up here. Haas Tooling. Go back to this. Anyway, for future tooling, we welcome our customers' ideas. If you scroll down here just below the blocks where we offer the different kits and apparel and all of that, you'll see questions, feedback, recommendations, contact us. Hit that contact us button over there and you'll send an email direct to the guys that head up the tooling department and our e-commerce program, and let them know what you, certainly your experience if you've used the tools, bought tools from our website and use them, but also something that's maybe not on our website now that you think we should be offering.
Yes.
We would like to hear those suggestions. Now, we think we're going to be offering within the next few months a variety that everyone's going to want and fulfill everybody's needs, but there may be something that we've forgotten about that you use that you'd really like, and we'd love to have you give us that feedback and let us know what you would like to see on our website.
So, and the other thing, and I'm glad you mentioned that, is you can now rate the tools. So it's like any rating system. It's 1 star to 5 stars, all on the website. And again, we encourage you to do that. We really want your feedback. You know, we know tools. Obviously, we use a ton of them, but we want your feedback because we want this website and our product offering to be what you guys want it to be. Okay, so coming soon, this table here that we're about to go through is all the tools that'll be coming on the website. Some of it in October, maybe some of it in November. Let's get started with these holders here.
Yeah, so the first thing we have here is 50 taper mill chuck. This one is used because we use it in our machine shop and have for many, many years. I don't know how long this thing's been in service. We don't have any of the actual versions because everything we got to test is actually running out in the machine. So we got an older version just to show you, but this is coming very, very soon. Also up here in the front, we've got the shrink fit holders. So we're looking at offering shrink fit holders and also in the future shrink fit machines to heat up the tool and insert the tool and get tools out. So again, coming in the future, but here's the shrink fit holders. I love these holders because they've got the holes right in the face for the through spindle coolant, so you don't need slots down your end mill or some have a hole through the center of the end mill. You can put any end mill in there and have TSC coolant spraying right at the tip of the tool. Down the flute. So there's a couple of sizes of shrink fit, and here's a drill chuck, comes with the key. Fantastic offering of new tool holders that'll be coming soon.
Now we've gotten a lot of requests for these, and these will finally be coming soon. So.
Yeah. So drill sets, these are all cobalt, tin coated cobalt drills, and we've got them in the number sizes, letter sizes, and down to the fractional sizes as well. So there's a full range of every possible hole size that you need to drill within, the largest one here coming in these 3 kits.
Right. Okay, moving on, a couple of
chamfer mill, inserted
mills.
chamfer mill. The every good machine shop takes all the sharp edges off of the machine in the CNC machine before the part comes off. So these are fantastic. There's a 2-flute and a 3-flute version of the chamfer tool. These are great for obviously chamfering the top edge of a part, but with the relief angle on the shank, you can get to the bottom and chamfer the bottom edge of a part before it comes off the machine. Very versatile tools.
Okay, so now we're going to get into the land of lathe tooling. And if you guys watched the mill turn, the VMT 400, yesterday morning, I believe it was, Bop Singh was doing that demo. Bop Singh has been supervising all the lathe tooling. Now, Bop has been here even longer than you.
Yeah.
Bop's been here over, I don't know, maybe 25 years, definitely over 20 years. So explain some of the tools that'll be on the website.
So some of the lathe tools that we've got coming, here's a part off tool holder and the blade that goes in that tool holder, the inserts that go in that blade. The tool holder comes with its hex key to tighten the tool holder in there, as most all of the tools that we offer come with its hardware to install the tools. If we roll over here to the next one, we've got a boring bar and the Torx wrench that comes with that boring bar. Here's the inserts for that boring bar. I've got a smaller CNMG tool holder. Again, that tool holder comes with the Torx wrench. And then next size over, CNMG 432, your basic workhorse in turning. And each of these tool holders with the top clamp style come with the 2 hex keys needed to install those inserts. Here's the larger 1-inch tool stick with the trigon style insert. The next one is the 55-degree diamond tool holder in the 1.25" size for your larger machines. Again, they all come with the hex keys. On the next placard here, we've got a variety of different inserts that are coming. This is an ID grooving insert that'll screw onto the end of a bar, and then a couple of different sizes and styles of lay-down threading inserts, and then a CNMG boring bar insert there on the end. So just a variety of lathe tools that's coming in the very near future.
Yes. Okay, and now again referencing Bop Singh and that video that he and Andrew did on the mill turn, he actually demonstrated this. If you want to see a demonstration of this, pull up the live stream from yesterday morning and you'll see it, but you can explain what it is.
So this is a collet chuck. This is an A25 collet chuck, and one of the collets that go in there, and then the quick change gun that comes with it to quickly install new collets, change out the collets. So we offer these we will be offering these in an A25, this one, and then a larger A26, which is the one that was actually installed on that mill turn that Bob showed.
Okay, and then these are interesting. This is an interesting story because we thought these wouldn't work, but we were wrong.
Yeah.
So
these are tool holder vices for tightening your either pull studs or shell mill bodies or whatever on your tool. So there's a vertical place to hold the tool vertically, and we looked at this and thought, I had never seen anything like this.
It'll never work.
There's no clamp. How does this work? Well, it's got the actual taper machined in here. And the way this locks into the V flange on the tool, it's actually locked in there really, really tight. You can lift it in and out very easily, but when you're trying to turn to loosen, even pulling up on this thing, it doesn't pull out of here. It was kind of magic.
Much to our surprise.
Yeah, absolutely. So really cool tool holder vices. I like them very much. Can't wait to get them in and get them on the website.
And we've got a 30, 40, and a 50 taper.
Yeah, 30 taper. 30 tapers here in the center, 40 taper out there, and then the 50 taper.
Yep. And I should mention, these are CT40, CT50. We will have BT everything coming, tool holders and everything, as well as HSK. So that's more coming in the future. We don't have it displayed, but know that we will have that on the website in the near future.
Yeah, BT and metric. All the tools will be available in metric sizes of those tools soon. Okay, so we're leaving cutting tool land and coming over here, and let's talk about work holding. So this is kind of another phase that we're going with HaasTooling.com.
We've got a variety of different kind of vices and fixturing here. The two that will be available immediately, and I believe in October, are these two 6-inch vices here.
Yeah, 6-inch cast iron vices. We've got the wide base style here that bolts down in 2 places here, and you can also put toe clamps on it. And then we have the narrower base with 2 sets of slots that'll line up with the T-slots. They come with keys that you can put on the bottom, and then you drop the keys into the T-slot, and you don't need to square that vise up. I did one the other day on the UMC 1500 Duo, and the thing was about 6/10 of an inch across the entire 6-inch.
Pretty impressive.
Yeah, as I set it in there. And that wasn't even, there's a little tiny bit of play in there, but that was just pushing back on it and bolting down. And that also comes with the bolts, toe clamps, bolts, and T-nuts.
You won't buy this vise, go to put it on your machine and go, oh crap, I don't have any hardware.
Yeah, all your hardware's tied up on other machine.
Right.
No, you'll get
Comes
a set
with
of
everything.
hardware to attach this to your machine with the vise.
I want to mention while we're talking about this is we will also be offering vise jaws and even vise handles, because what shop has not lost a vise handle?
Yeah.
Every shop has lost a vise handle.
Aluminum soft jaws for machining will be available for all of these as well in the very near future. Obviously, these vices come with a vise handle. That segues us over to the self-centering vise, and this was actually the vise and riser combination that we had on the UMC 1500 Duo this morning. But the comes with the ratchet and the 12mm socket to tighten and loosen this vise. Really high quality grind on all of these jaws. The jaws are serrated and dovetailed. If you can get a good close-up of this right here, you can see an example of the serration that will bite into material if you're holding on to the edges of material, or you can even put a 45-degree dovetail on the bottom of your part, 3mm or 1/18 thick, and this will hold it. I use this exact vise style on the VR8 demo that we saw earlier in this week. So here's the version of this vise that's mounted on the riser here, and then we also have a low profile version of the same vise. Very, very nice. Bolt down through the center. You'll also be able to get toe clamps that clamp on the side of this vise. This one doesn't have that capability because it's the low profile, but the larger version does. Really terrific vise. Very, very happy with it. One of the things I really like, let me see, is it, yeah. So it's calibrated over here, and these are millimeter sizes here, but this, if you know how wide you need to open your jaws to, you just keep cranking the handle until you get to that number, and that's how wide it is. I really like that feature. That came in very handy, having the scale
gives you that
etched
visual
on the side of the vise.
Right. Yeah. Okay, and then the last thing on this table here is a 0-point clamping fixture.
So this will be coming soon. A 0-point clamp fixture, pneumatic. We'll have the same 0-point is actually currently available on our TRT 210 as an option on our TRT 210 rotary. And then we're working on more setups for 0-point, but essentially you can make this a fixture, you can mill this out, put any pattern you need to put your part on there, and then you can use the 0-point to put this inside of one machine.
Okay, let's
pull this pallet off.
Most people know, but just in case. So super quick, yeah, to your point, you got a fixture to pallet, and clamping it is as simple as that. You're done.
Pull that pallet off, you can take it to another machine, and it'll be, you don't have to indicate it in, you don't have to pick up the 0-point if that other machine has been calibrated with the, or your work offset has been set to the center.
To the center,
yeah.
right.
So excellent tooling capability coming in the very, very near future.
Great, so that's kind of a tour of current to future. We've got one last thing that we want to show you. So I'm going to bring in Andrew and Mitchell O'Meara, who's just joined our video team, and they're going to talk about this tool presetter. Andrew, it's all you.
Thanks, Brian. So before we wrap things up, like Brian said, we just wanted to introduce one more thing that we've got coming on the horizon here soon. This is the HGS 400. Probably plenty of you out there are like, pretty obviously it's a tool presetter.
Yeah.
So for those of you who know what that is, that's great. But maybe you can run us through real quick why you want one of these in your shop.
Yeah, so for those of you who haven't encountered a tool presetter before, essentially what a presetter does is it takes the operation of touching off and setting your tool offsets as an operation that has to be done primarily inside of your machine to something that can actually be done offline. So it allows you to continue to be making parts and continue to run your spindle, but while still being able to touch off your tools and set up tools for either replacing the tools that you have in your current job or setting up a brand new job, and so you can continue to make parts, and that just allows you just to make more money at the end of the day.
You're running your spindle longer and more often per day, so you're making more money.
Exactly.
Cool. So something that's going to pay off for sure.
Oh, definitely.
So why don't we just take a quick look at how this thing works?
Yeah, so it's pretty easy. So I have a tool sleeve in here for a Cat 40 holder because the tools I'm going to be measuring are Cat 40s. But we also have different tool sleeves for a BT30, a Cat 50, or even an HSK. And those you can easily just swap out in between different operations.
So that just drops.
It just drops straight in.
Kind of a real close fit.
Yep, and then each time you swap it, you quickly calibrate it. But it's a very simple process, and it allows you to, even if you have multiple tool holders for your shop, you can actually use the same tool presetter for all those operations.
Cool. Let's look at how it works.
Yeah, so you go ahead and you start by grabbing whatever tool you need. So in this case, this is going to be a 3/4 inch Cat 40 end mill with 4 flutes. I just set it and just drop it down right here into my tool sleeve.
So it just sits in there with gravity, right? You're
just
not
sits in there with gravity.
anything.
Yep, and then when you calibrate it, it makes sure that you have
you've cleaned everything.
Exactly.
No dust or
Exactly.
stuff
Sometimes you have dust, you just clean off the top, and that's really easy. So once it's set in there, you actually want to rotate the tool while it's in there. And so what this does is it allows you to go ahead and set the largest Z height, which is going to be the length of your tool, as well as the X diameter height. So I just come over here, and it'll automatically adjust each time
as
it's going around.
So you kind of spun that around until you found the high point of the tool.
Right, and so as I continue to spin this around, it'll auto update to find whatever the largest height is. And so sometimes it could be 1,000, sometimes it's a 1/10. But once it finds that largest value, once you've gone around, and I have 4 flutes, so I rotate it around 4 times so that I can measure each flute. Then this go ahead and it saves the X diameter offset as well as the Z offset.
Right, so Z tool height, X diameter.
Exactly.
Measurement.
So
Okay,
in this case, this 3/4 inch tool is actually a 0.746 is the actual diameter. And so for this machine, I go ahead and I just click the save button, and that just saved my offsets for this tool. And so now I can use the same offset and load it up into my tool and be the exact same thing as if I were actually using the whips program or touching it off manually in my machine.
So you actually have a file system in here, of course, that stores whatever tools you are measuring, right?
Yeah, so I actually go ahead and create a machine. So if I wanted to say I had a VF2 SSYT, so I can go ahead and I can create a tool. So I can create a machine, for that tool. All my tooling lists to be able to be on there. And so I can actually go in and on that certain machine, if I want to export machines, I can just select and create a tool library for that job and then export it. And so you can have, I think, up to 999 tools on each machines. So you have plenty of space and ability for how many tools you use.
So once you've created a folder in there, let's say you checked a tool initially, then once you load a new end mill or you put new inserts in that particular tool, you just come back here and measure it, and it updates that particular. You select that file and update that particular one as the differences in length and diameter change slightly, right?
Correct. Yeah, so you can either use this for if I'm touching off a brand new tool, or if I'm going in and I want to do part inspection, so I can pull it from my machine after a job and I can put it back on there and see, measure the new tool geometry after I've already machined with it.
Right. Okay. So now I have measured it and I have my dimensions in here. How do I get that into the machine?
Yeah, so you can go about it 3 different ways. You can just take down these measurements and just write write them down, and then you can go over into your machine, into your control, and just fat finger them in, just write them in that way. And so you can do that very easily. Or what you can actually...
Like maybe you're doing one or a couple tools that way.
Right.
Right.
And you can just easily just go over, or I just wanted to check something real quick. That's something that's very simple. Another thing you can actually do is take those offsets, because we created an entire tool list. You can then export those as an offset file onto a USB. And then you can go over into your control, plug it in, upload that offset file, and then it'll automatically update your tool geometries.
Right, so you might have a whole job you're going to update. You load a whole new job, 10 tools or something for that job. You're going to update all of that at once.
Correct. And so even if you have 50 tools and say I only want to update the geometry on 3 of those, I still create this one offset file. When I load it into the tool, it's only going to update those 3 tools and leave the remaining 47 tools totally fine. And so you can actually do this on both NGC and the classic controls. So you don't have to worry about, oh, does my control work? Uploading an offset file works for both
newer
of
older
the controls.
machines. This will work fine. Okay.
Right.
And then there's a third way.
Yeah, and so this is one of my favorites. So this is going to be exclusive for NGC controls. And so I can actually, when I create my tools and send my offsets, I can then actually print out a label with its QR code. And so when I go over to machine, I have a USB Bluetooth reader for the machine. And so I can take my QR scanner and actually just go straight and upload directly onto my control, and it'll upload the offsets onto the machine. So I don't have to worry about exporting a file. I can go ahead and measure all my tools, put labels on them, set them aside, and so when I need it, I can grab my tool, scan it in, put it in the spindle, and I'm back up and running.
So, and you also kind of have an indication that you've done that tool. It's just a visible indicator that I've measured that tool.
Exactly.
Cool. That sounds great. So now this thing is slotted for release?
Yeah, towards the end of the year. So actually, we're
end of 2020.
End of 2020. So around December is when we're projecting to release this. And yeah, I think this is going to be a really powerful tool for machinists to be able to add to their arsenal.
Yeah, it's good. It should pay for itself. Keeping the spindle turning more often every day.
Exactly.
Cool.
And you can use this small shop, large shop. It's going to save you money either way.
Very good. Thanks, Mitchell. So I'm going to bring Brian back in here. We're going to close this thing out. Thank you so much, guys, for joining us again today. We got one more day to go, right?
We got one day to go.
We're back tomorrow. Let me see if I can get it right. 9 a.m. tomorrow morning.
You got it. So 9 a.m. tomorrow, and then 11 a.m. tomorrow. Instead of 9 and noon, we're at 9 and 11. And at 9 o'clock, we're going to have somebody who's been not in any of these videos, strangely.
Yeah, right. Surprisingly.
Yeah.
But he's going to make up for it tomorrow, for sure. We're going to make him make up for it.
Mark Terryberry, Tip of the Day Live. He's got basically an hour or however long Mark wants to himself. That'll be at 9 a.m. Pacific, noon Eastern. So you're
we're going to be here in the demo room again.
We'll be here in the demo room.
I think he's going to be roving the floor here, doing a bunch of different stuff. I think he might even touch on this. We'll see.
I think he will.
Makes his way over to that, but it's going to be a wide variety of topics, I'm sure.
Yep. And then we're going to close out HaasTech 2020 with our general manager, Bob Murray, and that's going to be at 11 a.m. Pacific, 2 Eastern. Bob's going to give a presentation, and I can say that I have sat in on Bob's presentations many times, and they're fantastic. He's going to talk about what Haas is doing now, the future of Haas, all kinds of things, so you're definitely going to want to watch that.
Definitely want to stick around.
Let's mention the promo before we go out.
Of course, got to mention that. So don't forget, you've got one more day to get that extra 5% savings. That opportunity ends tomorrow night. I'm assuming at midnight or something like that. So get that extra 5% off the already existing great deals. There's a wide variety of machines that you can save money on.
Yep, you go to HaasCNC.com and you can't miss it. It's right on the home page, the home banner. Unlock the savings, that's what it's called. Click on that. And the beautiful part of it is you can absolutely talk to your Haas factory outlet, your salesperson, or you just go to the machine page you're interested in, do a build and price, and all those discounts are factored in, and you don't have to talk to anybody.
That's right, and you can make comparisons between, you can build and price a number of machines.
That's
you
right.
Can get, if you're thinking about several different machine configurations or even machine types, you can compare them. You can easily see what your outlay is going to be.
Yep.
So and then you can call your HFO from there if you want to.
When you're ready. Yes, exactly. Okay, I think that wraps it up for today.
That's right. Please join us again tomorrow at 9 a.m.
9 a.m. Make sure you go to HaasTooling.com and check out all the tools we have, because we didn't cover them all, and sign up for the Haas Buyers Club, and we will see you tomorrow morning.
That's right. Thank you, guys.
Take care.